Welcome to my projectbazaar.com. Now let's see about an atlas-based segmentation propagation framework using locally affine registration application to automatic whole heart segmentation. Now let's see about the abstract. In this paper, they segment the process by segmenting whole heart by the use of local affine registration technique. Instead of locally affine registration technique, we use the watermarking. Here we segment the whole heart in the cardiac MRI images. For segmentation, here we use the watershed algorithm instead of locally affine registration. Initially, we remove the noise from the image. For removing the noise, we use the VNR filter. For watershed algorithm, it needs inner marker line and outer marker line. For predicting these lines, we use the morphological function. Morphological operation is a collection of non-linear operations related to the shape or morphology of features in an image. Morphological operations rely only on the relative ordering of pixel values, not on their numerical values, and therefore are especially suited to the pre-processing of binary images. Morphological operation can also be applied to grayscale images such that their light transform functions are unknown and therefore their absolute pixel values are minor interest. In watershed, internal markers to obtain the watershed lines of the gradient of the image to be segmented. Use the obtained watershed lines as external markers. Each region defined by the external markers contains a single internal marker and part of the background. In watershed, regions without markers are allowed to be merged. This is the flow process. Initially, we have to give the input image as the MRI cardiac images. The cardiac images pass to the pre-processing step. Here we are removing the noise by the use of Gaussian filter. Normally the medical image may contain the noise while generating the image, so that we have to remove the noise by the use of Gaussian filter. Gaussian is the weighted mean function. Based on this, it will be removed. After removing the noise, it will go to the edge detection. For detecting the edge, here we are using the Canny edge detector. Canny algorithm basically finds edges where the grayscale intensity of an image changes the most. These areas are found by the determining gradients of the images. Gradients at each pixels in the smoothed image are determined by applying what is known as the Sobel operator. After identifying the edge, it will go to the morphological operation. Here we apply the morphological operation to remove the unwanted lines in the detected edge. It is a collection of non-linear operation is related to the shape or morphology of features in an image. Morphological operation rely on the relative ordering of pixel values, not on their numerical values. So that after removing the edge, it will pass to the watershed line. The removed marker line is used as the inner marker line. The inner marker line will pass to the watershed algorithm. Watershed transformation is a common technique for an image segmentation. However, it is used for automatic medical image segmentation has been limited, particularly due to over segmentation and sensitivity to noise. So after detecting the segmented result, finally we are showing the result in producing different colors. Let's see the demo of our process. Here I am having main.m file. Select this file, right click and run the file. So this is our guide design. So initially we got to give the testing image. Now I am selecting on image as input. This is the selected input image. This input image will pass to the pre-processing step. Here we are removing the noise from the input image. After removing the noise, it will go to the edge detection. This is the edge detected image to the input cardiac images. It is a Canny edge detection method. So after that it will go to the morphological operation. Morphological operation is used to remove the unwanted lines to the input images. So these are the unwanted line removal image, which is called the marker line. It will be the input to the watershed line. So watershed need the two input, that is the inner marker line and outer marker line. So the inner marker line will be identified by the use of filtering function. The outer marker line will be this input. So this is the segmented result of watershed algorithm. Here the hot image is segmented by the use of the watershed algorithm. Now I am showing the result of whole hot segmentation of MRI cardiac image by the use of watershed algorithm. Thank you.